Example 4, find all the zeros of this, given that 3 minus 5i is 0. So again, they're giving me a complex 0, 3 minus 5i, which means 3 plus 5i is also a 0. That's only 2, and since that's the fifth power, I actually need 3, which hopefully means there's at least one rational solution. And it's up to you to determine when to do this. Here's the thing. If I try and do the rational root theorem with this, 204, and start thinking about how many ways there are to make 204, 1 times 204, 2 times 102, 3 times whatever that is, it gets to be rather large. And each time I reduce the polynomial, the new polynomial has answers. It would be better to do some synthetic division with these two guys first, reduce it down to a cubic. Once it's down to a cubic, then do your P over Q thing on that. I can do my Descartes rule of signs at that point too. So again, use the answer they gave me along with its complex conjugate to get me reduced to a cubic function. The cubic function hopefully have something smaller than 204 as this last digit, or as this last term there. So, and basically I just have to set up my synthetic division. So 3 minus 5i, take one. It doesn't matter which one. I'm going with the one they gave me as my first one. I can just easily start with 3 plus 5i. It doesn't matter. My coefficients are 1, negative 10, 65, negative 184, 274, and negative 204. And do leave yourself some room, because you know you're going to get some binomial pieces in here. So allow yourself some room. Don't kind of. I had people trying to stick it in that space, you know, on paper, you know, equivalent on papers like that. You leave some space there to allow for some binomial pieces because they do show up. Sometimes they're all binomials, except for the first and last one. Obviously the first one's 1, right? The last one should be 0. The middle ones are the ones that are ugly. So if I go to my SynDiv program again, pick program 3, enter. It's a 5th degree polynomial, so 5 is the degree. Coefficients are 1, negative 10, 65, negative 184, 274, and negative 204. My root that I'm testing is 3 minus 5i. Hit enter, and we get all these answers. First one 1, last one 0 as we expected. The remaining ones are negative 7 minus 5i, 19 plus 20i, negative 27 minus 35i, and 18 plus 30i. And 0. Okay? My 30i a little prettier. My calculator's covering it up. Alright, so again, leaving myself space. We got a bunch of imaginary complex answers here, right? But again, those are the new coefficients of my new polynomial. Again, if I just hit enter here, it immediately runs the last program. That's why running SynDiv instead of SynDiv 5 and then SynDiv 4, you don't have to keep on hitting the program button. Hit enter after you're done. It brings you right back. Because typically when you're doing this, you're doing complex numbers, and complex plus its conjugate, you tend to do it twice. So running the SynDiv program is helpful. The degree is 1 less, so now it's 4. My coefficients are 1, negative 7 minus 5i, 19 plus 20i. Most people who start using this to begin with, they forget to hit enter after each one. That's the typical thing that people do. And it gives them a frustration because they can see right there, like once they hit enter and it says syntax error, you got a bunch of numbers just strewn about. But yeah, just make sure you hit enter after each one. Negative 27 minus 35i, and finally 18 plus 30i. My root this time is 3 plus 5i. The other thing, make sure if you did a minus on this one, do a plus on that one. Make sure you do the conjugate. If you do the same thing twice, it doesn't work. It just makes a big mess. So 3 plus 5i is my root. Hit enter. 1, negative 4, 7, negative 6, 0. And now we're down to a p of x, or q of x, we'll call it q of x because we've got a reduced polynomial here. So q of x now is x cubed minus 4x squared plus 7x minus 6. Now the factors of minus 6 are 1, 2, 3, and 6, right? Plus or minus? Instead of 204, which had I don't know how many factors, that would have been ridiculous. So again, we're saving ourselves energy by doing this. So always, if they give you answers, do synthetic division first to get yourself reduced to a smaller polynomial. Looking at the rational of the signs, Cartesian, Descartes rule of signs. For some reason, I just don't want to say Descartes rule of signs. We got 1, 2, 3 sign changes, so there's 3 or 1 positive. If we look at q of negative x, it's going to be negative x cubed minus 4x squared minus 7x minus 6. They're all negative, so there's no negative answers. These two changed signs, these two didn't. They're all negative after we changed the signs we're supposed to. No sign change. So there's either 3 or 1 positive solution, there's no negative solutions. And my possible rational roots, all the factors of 6 over all the factors of 1, so basically just all the factors of 6, are going to be 1, 2, 3, and 6. Again, I'm not even concerned about the negative ones this time because there are no negative solutions. Clear out my table before I start because I don't want to find more than 2 answers, more than 1 answer actually. At this point I just need to find 1 answer, right? Yep. We type in my cubic function here, which is x cubed, press to the right to get out of the power level, minus 4x squared, plus 7x minus 6. I'll stop saying that, I'll hold push to the right to get out of the power level when I stop forgetting to do it, because I keep forgetting to do it too. I'm going to try 1 and 1 doesn't work. 2 works. Okay, so 2 is the right answer. So at this point I'm going to do synthetic division with 2. 1, negative 4, 7, negative 6. Since I'm just doing it with 2, it's quicker just to do it by hand. 1 times 2 is 2, minus 4 is minus 2. Times 2 is minus 4, plus 7 is 3. Times 2 is 6, remainder 0. So x squared minus 2x plus 3 equals 0. That's the quadratic function. I can't factor that. So I'm going to go to my calculator, go to my program quad. And again, I got 1, negative 2, and 3 are my A, B, and C values, which is what it's asking for. 1, negative 2, and 3. And this comes out as a decimal, I. So whenever you see 1 plus something, 1 minus something, sometimes depending on the calculator, sometimes they don't show all this, and you'll see like this. The I is kind of hidden. It might have a little dot, 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 like it's got something else going on. If it doesn't show the I, just know if it's number plus number, number minus number, they're imaginary. They're complex, so the I is over there somewhere hiding. Go about 3 decimal places, that'll be sufficient. If you recognize 1.41421356 as the square root of 2, that'd be great. But if not, that's fine. I mean, the square root of 2 is pretty straightforward and noticeable, but some of the other ones aren't as noticeable. So 1 plus 1.414i. 1 minus 1.414i. Of course, 2 was a root, right? My other 2 roots were 3 plus and minus 5i. So 3 minus 5i. Each one only occurs once, so no multiplicity happening in this one. And there's what you get for the whole problem. Find all the zeros. Again, anytime they give you a complex answer, use that to reduce the polynomial before you do your possible rational roots. So it's easier. Too many, only 4. So it's just a better deal.